Our goal today is to graph relations and to identify functions. All right, so the first one is a relation, and all a relation is an example of it would be a coordinate point. So a set of input that has output values. So your input is like your x value, and your output would be your y value. So a coordinate point is a relation. A relation is going to have a domain. So those are going to be the input values of the relation. In the example of a coordinate point, the input or the domain are your x values, so the x coordinate. And the output or the range is going to be your y coordinate. Okay. And then it says a function. Now, you guys, does anyone remember, just raise your hand, you don't have to tell me the definition or anything. Does anyone remember hearing about what a function is in Algebra 1? What is a function? Does anyone remember that term? You don't have to tell me the definition, but if that just sounds familiar, I want you to raise your hand. Who remembers that term? Only one? I feel like a lot of people usually remember this. Maybe once I describe it, then maybe I'll see more hands. A function is a relation where each element, that's what that funny looking E is, an element, of the domain is paired with exactly one output. Okay, so one element of the range. Okay, so that means if you're looking at a coordinate, your x at 2 cannot have two different outputs. It cannot have two different y values. And we can tell if it does by the vertical line test. Maybe this is starting to ring a bell. If a vertical line passes through no more than 1 point on a graph of a relation, then it passes the vertical line test and the relation is a function. Okay, so I'm going to show you one that passes and one that fails. So if we have a coordinate plane, here you go. Maybe you have a point here, maybe you have a point right here, maybe you have a point over here. And what happens is if you take a straight edge, and you can start over here, and it cannot pass through more than 1 point. So as we go along, it passes through 1 point here, but over here, see how that vertical line is going to pass through 2 points. Do you see that? Because it passes through 2, this fails. Okay? And since it fails the vertical line test, we can say that this is not a function. All right, so then we'll draw another example here. Maybe we have a point here, maybe we have a point here, and maybe we have a point over here. And what happens in this one is you can draw a vertical line anywhere, and there it only passes through 1 point, and here it only passes through 1 point. It works a lot better when I actually have a grid so I can see the vertical line a lot better. But this is just an example. There I have a vertical line, and nowhere does a vertical line pass through more than 1 point, and because of that, this one passes. It's got a passing grade, and this is a function. Okay, and they don't have to just be points either. It could be a curve. Like maybe these points were all connected like that. And that would still be considered a function because even though it's a curve, every point of that curve is representing a point. So there are more points than what we just drew. It's just those represent infinite number of points. Is that okay? Raise your hand if you remember a function now. Like, oh yeah, I do remember learning that. I remember doing the vertical line test. Okay, so there's more hands. So now that we saw it, it looks a little bit more familiar. Okay, usually that's one that people said for whatever reason, they remember learning about functions. All right, so we have to graph a relation. And when we graph a relation, we just are graphing the coordinate points. So let's draw in our axes here. And I think I brought it up on like one of the first days of school, but if anyone purchased a compass last year, one like this, in geometry, these work great for straight edges, so they're really good, awesome to have in your binder to work as a straight edge. Otherwise, you can use like the edge of your binder, or if you have a ruler that you can stick in your binder as a straight edge, it's awesome because we like to make sure our graphs are nice and neat. They're much easier to read when they're neat. All right, so there are this is my x-axis here, and this is my y-axis. Some people remember because y is like a yo-yo, and yo-yos go up and down. That's how you want to remember it. I don't care as long as you know x is horizontal, y is vertical. I'm golden, you're golden, we're all golden. All right, let's put some numbers. We always have to put scales on our graphs. I'm just going up by ones. I'm labeling every other one, but I am going up by one. So when I count this, I'm counting 1, label 2, count 3, label 4. Okay? Be very careful. Many years, and I'll show you exactly. Many years I'll have people label this very first line as 2, and then start labeling every other. If you want to label every other, you're going to have to skip that first one. Okay, so always make sure that that first one counts as 1, the second one counts as 2, the next one is 3, then 4. You always want to make sure you count every line to make sure that your scale is actually accurate. What I mean by that, I'll show you. Some people go like this. And they count this first one as 1, and then they count every other, 2, 3. But if that first one is 1, you just set your scale to 1. So that's 1, 2, 3, 4, 5. So these are no longer right. Does that make sense? So it is important that you know how to graph. So just be careful on that. Okay. So plotting these points. Actually, before we even plot the points, I want to tell you about quadrants. When you draw in your y and your x axis, it breaks it up into 4 parts. They're called quadrants. This is your quadrant 1. This over here is quadrant 2. This one down here is quadrant 3. And this one over here is quadrant 4. Okay. So we're going to actually go through and graph those points now. So -2, 4. These are in alphabetical order, so they're x, comma, y. So our x, we're going to go to the x scale. We're going to find -2. We're going to go to the y scale. We're going to find 4. So it needs to be at this line, and they meet right here. Give me a 1 to 5. I'm pretty confident I can plot coordinate points. Down to a 1, I've never plotted a coordinate point in my life, nor have I seen a coordinate point before. Okay, so we're going to plot the other one. So we have 3, -2, so we're going to go to the x. We have to go to 3 on the x, to -2 on the y, or right here. The next one is -1 on the x and -4 on the y, which is right there. 4, 5, so right 4, up 5, right here. A -6, 4, it's going to be right there. Okay. So Once we have that graphed, we have to ask, is this a function? And is this going to be a function? Since it's a graph, it's easy to look at the vertical line test. Is it passing the vertical line test here?
Yep.
Okay, I'm going to slide it over till it hits another point. Is it passing right here? Still is. How about when it passes through this one? Yep. Next one is this one. Does it pass? Does it pass? There's no other points to check. So is this a function? Yes. And we're always going to be asked to explain. So we can say, yes, it passes the vertical line test, but you have to then explain, if you want to use the vertical line test, you have to explain, why does the vertical line test show me that it is a function? Passes the vertical line test. So each input, or you can say, yeah, each input has exactly one output. That's the big idea here. Each input has exactly one output. If you had a -6 have two different y values, okay, then it wouldn't be. Okay, but you can say that each input has exactly one output, and we're done with that example. All right. So being able to find the domain and range. Your domain are going to be your x values. So our x values are an element of, and then we make the list, and we put those lists in brackets, like this. And we just list those x values. So we have -2, 3, -1, 4, -6. I like to list them from least to greatest, so I don't have any repeats in my list. So my smallest number is -6. And then I have -2, and -1, then 3, then 4, and I'm done. Your range are going to be your y values. So y is an element of, we have 4, -2, -4, 5, and 4. So we're going to look and we're going to list those from least to greatest. -4 being the smallest. And -2. 4 and then 5. Now the reason I chose to list these from least to greatest is so that I don't have any repeats in my list. Okay? You can see that 4... Is it 4? Yeah, 4 is the repeated number here, but I'm not going to write 4 twice because it's the exact same number. And this is just a list of my students. It's kind of like, who in here goes by a nickname? Jack does. So Jack, your name's actually John, right? So if I named you as John and as Jack, then it would look like there was 2 separate people in my class, but really there's only one of you. So I would just have to list one of those when I would be listing everybody in the class. Does that make sense? So there can be, you don't have to tell me all the different things it can be called, even though 4 is just 4. You just have to list it once. Okie doke. All right. Is this going to be a function? If you look at this, can you tell by the points if this is going to be a function? It is a function? No, this one's not a function. How come? Wait a minute. This is a function, right? Because you have to visualize it. And a lot of times people might say no at first because they see those 2 4 values. But they have different inputs. So inputs, it says each input has its own output. There are no double inputs. Okay, that's what we're looking for here. Okay? So our answer is going to be yes. Because each input has exactly one output. Okay, so even though there's an output that's repeated, that doesn't matter because -2 is an input that goes to 4. So negative 2 only has one output. Negative 2 is only going to 4. And negative 6 is only going to 4. So still only has, each input has exactly one output. Okay, so it's not like negative 2 is going to 2 numbers, or 3 is going to 2 numbers, or negative 1 is going to 2 numbers, or 4 is going to 2 numbers, or negative 6 is going to 2 numbers. Okay, they're each only going to one number, which is what makes it a function. All right, so then we have another series of points. I want you to name the domain and range here. So I'm actually going to freeze my screen so you can't see what I'm writing. I want you to come up with the domain and the range. And I'll give you a hint that on my keys, I usually do it from smallest number to greatest number. So for easier to check, it might be easier if you guys always go from least to greatest. How do we feel about our domain and range here? Give me like a 1 to 5. I'm pretty confident I have them correct. Down to a 1. Never heard of these terms before. Okay. So let's look. How do we do? Are we doing okay with those? You have the x's for your domain. Your y's are your range. Next is this a function?
No, because negative 2 has 2 outputs.
Yes, this is a no. And your explanation is because negative 2, which is an input, goes to 2 different outputs. It goes to both 8 and negative 4, which are your outputs. So since it has 2 outputs, that is not going to be a function. Do we see the difference? So this one has your x values that repeat. Your x value, there are 2 of the same x values. And so there's your input. And is your input going to 8 or negative 4, it has 2 different numbers that it's going to, so that's why it doesn't work. Here, when you're looking at all your x values, there's no repeated x values. So that's kind of your hint. You're looking for those repeated x values. If your x values repeat, then you can visualize on your graph, you'd have at one spot of the x, it goes to 2 different spots, which make that vertical line, which will not allow it to pass that vertical line test. Can you kind of visualize what those would look like on a graph if you plotted negative 2, 8 and negative 2, negative 4, and how they would be directly on top of one another, which would not allow it to be a function. Fine. All right, so let's talk about this one down here. Your domain here. It's almost as if you have to squish this on the x number line, okay? If I were to take and squish this on the x number line, I would have a solid dot here, and it would go to this end, and I'd have a solid dot there. If I squished this graph onto the number line, onto the x number line, now your x is your domain, right? So how would I write this inequality if it's between 2 numbers? How could I write that? How would you write this as an inequality if we were back in like 1.4 day 2? Is it going to be an and statement or an or statement? It's an and statement. And in what 2 numbers is it between? Because I want to write it like this. Negative 5 and negative 1. Does it include negative 5? Does it touch negative 5? Yep. So I'm going to include it. Is it touching negative 1 ever? It does up here because it has a solid circle, and the solid circle is going to overtake that. So there you go. So your domain on a graph like this is going to be anywhere from negative 5 to negative 1. Can you kind of picture how that squishes onto that line? Can you see that? Now if I take and I squish this graph onto my y, because my y is going to be my range, I'm going to do the exact same thing. I have a solid circle here. And you see how if I squish it onto that y, that's where it's going to be. All of this will be shaded, and I'm going to have an open circle right there. Can you see that? Okay, so now if I turn this sideways, so it's like I'm looking at a number line, just like I was in 1.4 day 2. I'm going to have another and statement. It's between two numbers. What two numbers is it in between? 2 and negative 2. So I'm going to write the negative 2, x, and then 2. Okay, does it include negative 2? No, because there was an open circle there, so I have a strictly a less than sign there. Does it include positive 2? Yep, because there's a solid circle there, so I'm going to have less than or equal to. So that's how I'm going to write those ranges when it's not just a series of points, because there are an infinite number of points in between those 3 points that are labeled on our graph. Okay, when it is a line, or a curve, there's an infinite number of points on that curve. Okay. Is this a function? No. Nope, this one's not. It wouldn't pass the vertical line test. Okay. We've already written our explanations for that, so I'm not going to write out an explanation again, but you could just say that each input has actually 2 outputs in this case, which makes it not a function. They have to have exactly 1. All right. How about you guys try your domain and range on that second one? Because I want you guys to try this, because for some reason this is what confuses people, is squishing it onto one number line. So I want you to try finding the domain. So squish it on the x. What would your number line look like? How would you write it? And then squish it on the y. Okay. All right, how did we do? Give me the 1 to 5. I did awesome. I'm really going to need some help on this, which that's okay if you do. We're going to have more practice. I'll take a look, and if you guys have questions, now is a great time to ask. Can you visualize what it looks like to get that like teal color, how I squished it onto just the X, and how this was here and I had all these spots in between, and then this is where it stops from left to right, and I have a closed circle right there. And then I just have to write my inequality like I would have before if that's what my graph looked like. X was between those two values. It doesn't include that. It includes that. Yes? You always start with the smaller number and always have less than signs. So like your signs have to always go the same way, because if I were to eliminate that X right there, -3 has to be smaller than +3, which is why you have to have less than signs, because no matter what part of this you look at, it's going to remain true. X is bigger than -3, X is smaller than 3, and -3 has to be smaller than 3. So it doesn't matter which part of this you're looking at. So I always write them with less than signs and go from left to right with the smallest to the largest number. Does that help? Okay. Technically, you could write this 3 is greater than or equal to x, which is greater than -3. I just don't ever write it because that looks backwards to me. So, other questions so far? Okay, so is this going to be a function? Is this one a function? Yep, this one is, because it would pass the vertical line test. You're not going to look at the pink and the blue lines that we wrote, but on that black line that it actually originally, that curve that it originally was, it never fails the vertical line test. So because of that, this is yes. That's a function. And maybe you wanted to answer that first before you put those other lines on there so it doesn't confuse you. You could do that too. All right. This next one, this one's a little bit easier. These are just points, so you could go through and write out each coordinate point. Or what I like to do is I say x is an element of, and I just use a straight edge and say, okay, it hits it here, that's at -4. And it already puts it in order for you. -3, -2, hits it again at 0, 1, 2, and 3. So there's your domain. And then you can do the same thing when you're working on the range and just start from the bottom. So the smallest number. -2. Doesn't hit it again till 0. And then 2, 3, 4, and done. Is this a function? Yep, looks like it. That one works. Okay. The mapping diagram. This one, all you're going to do is you're going to list your domain just like we were doing up here. I usually list them from least to greatest. So in your domain here, you have -2 would be the smallest, then -1, and then 3, and then 4. So there's your whole domain. The reason why you want to list them from least to small, or from least to greatest, is so that you don't accidentally repeat numbers, because again, even though -1 is on there twice, I don't want to write it twice, because then it defeats the whole purpose of this mapping diagram. Okay, the range, we have -4, -2, 0, 4, 5. And then in order to complete the actual mapping part of this, you're going to look at the point and you're going to say -2 goes to 4. So you're going to map it like that with an arrow. And 3 goes to -2. -1 goes to -4. 4 goes to 5. And -1 goes to 0. Now, is this one a function? Does each input go to exactly one output value? No. And you can see -1 is going to 2 locations here. So we can answer no on is this a function? Okie doke. All right, so then function notation. This is something that you guys have worked with a little bit in the past. Probably not a whole lot, but function notation is going to become a lot more second nature to you guys because it's something that we do very often in Algebra 2. So f of 2 says, what do you get for your y value when you plugged in 2 for your x value? So what we're going to do is we're going to find f of 2 first. So on the side here, we're going to write f of 2 equals, and we're going to plug it into our function f. Okay, when we use function notation, it's nice because we can name different functions. We can have two different functions given to us. They're not all y equals and have to talk about, okay, which one is it meaning? You can actually visually see, okay, I'm going to use the f function here. I'm going to use the f function here. I'll use the g function over here because each function has its own name or letter, per se. All right, so f of 2 is equal to 3 times 2 plus 4. So f of 2 equals 6 plus 4. F of 2 equals 10. That means when you plug in 2, you're going to get 10. So I'm going to replace this with 10 minus, shoot, I'm going to have to also figure out what f of negative 1 is, so I can plug that in there. So f of negative 1 is equal to 3 times negative 1 plus 4. I'm just plugging in that value for x. So f of negative 1 equals negative 3 plus 4. F of negative 1 equals 1. So now where there was f of negative 1, I'm going to replace it with 1. I should probably put those in parentheses. So what this is actually asking is, what's 10 minus 1? Well, that's not all that difficult. That's just 9. So this might be new to you, but you should have already done in the past what is f of 2 and you'd have to solve something like that. Is that okay? Now, in this next one, this whole thing is on the inside, so we're actually going to plug that into the whole inside. So f of x plus 1 is equal to 3 times whatever we have for x plus 4. But what we have for x is x plus 1. So then all you're going to do is look to the right side of this equation, and if that was an expression that I asked you to simplify, that's all you're doing, which we practiced in Unit 1, how to simplify an expression, which is why I'm confident you guys know how to simplify 3 times the sum of x plus 1 plus 4. So the first thing that you're going to do is distribute. So we have 3x plus 3 plus 4, which is 3x plus 7. So f of x plus 1. You're not doing anything on the left side. Okay? You're not doing anything there. That's what you're trying to find. But what you ended up getting was 3x plus 7, so that's your final answer. Are we okay so far? All right, number 2 is f of x plus g of x. 2 times f of x plus g of x. So what we're going to have here is 2 times f of x is equal to 2 times, what is f of x? Was 3x plus 4. Again, you're not going to touch the left side. That's what we're trying to figure out. So we're just going to go and simplify the right side. All you're going to do is distribute that 2. Oops, plus 8. So that's what you're going to replace 2 times f of x with. Plus g of x. You don't even have to do anything on this one, because g of x was already given to you. And then all we have to do here, since it's just adding, combine like terms. So really the parentheses aren't even necessary. You could get rid of them if you wrote them in. And you're just combining like terms. So 6x and negative 2x is 4x. And 8 and 5 is 13. And that's it. Is that okay, that idea?